My name is Robbie Olaide Cordial, the lead educator of Rock Math class. Your idol welcome back to Rock Math class. This is going to be our second lesson on Fourier series, and we'll be dealing with what with some examples on Fourier series. In our introduction of this Fourier series, I made it clear that before you can use Fourier series, you have to confirm maybe the function you are giving to you is even or odd or neither. So you can know the part of the Fourier series you are going to use. Now let's move to our first problem on this Fourier series. So we have problem 1, Fourier series of what of period 2 pi. Expand the function. What's our function? Our function is giving us f of x. If you have minus pi minus into the bracket of pi plus x all over 2 on this given interval, minus pi less than x less than 0. And the second function that we have is all over 2 on this given interval, which is 0 is less than x less than what pi. So is what we have to expand this given function in Fourier series. So let's move, guys. Now this is my solution. Now let me take the first function that we have above, which is f of x is equal to minus into the bracket of pi plus x all over what 2. And which given interval? We have this our given interval as minus pi is less than what x and x is less than what is 0. Let's call this one what equation 1. Equation 1. So the first thing that you have to do is that because I want to confirm maybe the given function is even or odd. So is that I have to replace what? Replace x by minus x. So we're going to have this f of what minus x now. So this is same thing as we have f of minus x. Whenever I see x in this equation 1, I'm going to replace by what? By minus x. So I have minus into the bracket of what? Pi. I have my plus. Then this is my what? Minus x. Over what? 2. Then it will also affect this my given interval. So I'm going to have minus pi is less than what? Minus x. Then less than 0. So this is same thing as what? As f of minus x equal to what? Minus into the bracket what? Pi minus x over 2. Then the nature of our interval is going to change as my pi now will be greater than what? Greater than x, and x is now greater than what? Is 0. So this also can be written as f of minus x is equal to minus pi minus x all over 2. So the interval will now be what? In the normal form of itself, now which is 0 is less than x less than what? Pi. That is, by taking it what? By taking it from the back side now, I'm now getting for 0 is less than x and x is less than what? Pi. So this is now going to give me what? Equation what? Equation 2. So now let's move to the second given function. This is our second given function, which is what? Which is x minus pi. Now, x minus pi. So we have our f of x is 2. On which given interval? Given on our this given interval as what? As 0 is less than x and x is less than what? Pi. Equation 3. So the next thing that I'm going to do is to replace x by what? By minus x. So we're going to have f of minus x is equal to what? Minus x over 2. Then we have 0 is less than minus x less than pi. This is the same thing as f of minus x is equal to what? Pi plus x over 2. So I'm going to have is 0 now is now greater than x and x is greater than the minus over here. The minus over here will be transformed to this pi. So I'm going to have what is greater than what minus pi. So therefore we are going to have f of what minus x now is equal to what pi plus x equal over 2. Then what's our interval now? I will take the interval from back now, from this side. I'll take it to this, take to this. So which is same thing as minus pi is less than x less than 0. Equation 4. So the next thing that I'm going to do now is to write out all the 4 equations that I have above. All the 4 equations that I have above, which is what? Equation 2, equation 3, and equation what? 4. So that we can compare maybe the function what is even or odd. And let me write out the given equation that I have. My 4 equation, which is equation 1, equation 2, equation 3, and equation what? 4. If you look at this carefully now, let me try to flip my tab. If you look at this carefully, you can see that equation 1 and equation 4. Equation 1 and equation 4 are the same, or they have the same interval. And equation 3 and equation 2 have the same interval. So now, we should also recall that before you can say any function is what? Is even or is odd. Now, if the f of x is same thing as what? Minus f of minus x. Now, we are going to say what the function is what is actually. Now, let's go on and confirm it now. If you look at our equation 4, you can see the interval now. We start from what? Minus pi to what? Minus pi is less than x less than what? Is 0. So in this case, now let me try to flip it again. This is what I'm trying to say now. Is that if you look at it carefully now, we have what? This our equation 1, which is f of x here. And our equation 4, which is this one. You see it now, which is, from this part, we have what? Minus f of x. And both of them are what? They are on the same interval. Equation 1 and equation 4, they are on the same what? Interval. So, in this case now, if you look at the interval, the interval is what? Is from minus pi less than x less than 0. If I should take the second one, which is what? Which is f of what? Of x. F of what? F of x again is equal to what? Minus f of what? Minus x. That is dealing with what? Dealing with equation 2 and 3. Equation 2 and 3. This is my equation 2 and my equation 3. They are on the same interval. So this is the given function now. If I put it the negation of it, that is minus f of minus x of it over here, I'm going to have this guy back. So therefore, this we have on the same interval, which is what? Is 0 is less than x less than what? Pi. So once this thing I have satisfied now, what I'm going to do what? That function is what? The given function is what? Is odd. The given function is what? Is odd. And once the given function is odd, in this case now, once the given function is odd, your a naught is what? Is 0. And your an is what? Is 0. So we are only looking for what? For bn. We already calculate for what? Bn. And now that I want to calculate for bn, I'm going to use this equation that has from what? From 0 up to what? Up to pi. Which is what? Which is the second given function. Which is this. Which is this. So now we are making use of what? Of our equation 3 now to what? To calculate for the Fourier series. Now let me write out the equation 3 that I'm dealing with. So the function that I'll be dealing with right away now, since the function is odd, is x over 2 from what? Is 0 is less than x less than pi. So this is what I'll be using. And now we won't calculate for what? For a naught, because our a naught is what? Is 0. And what? Our an is also what? Is 0. So we're only calculating for what? For bn. So let's move, guys. So let me write about calculation for what? For Bn. And don't forget to recall that our Bn is same thing as 1 over pi, the integral of what? Of minus pi to pi f of x sine nx dx. We are calculating for what? For Bn. Now, since I'm not using for what? I'm using the interval from what? Is 0 to what? Pi. So this Bn can be written as what? My Bn is also what? 2 over pi from the integral of what? Is 0 to what? To pi. And the function that we have now that we are calculating is what? Is n minus pi, n pi minus x over 2. So you have pi minus x over 2, then sine nx dx. So this is what we have right away now. So if you look at this carefully now, you can see that this guy over here, these two can cancel out these two. So therefore, our Bn now is now something as 1 over pi, the integral from 0 to pi of what? Of pi minus x sine nx dx. This is what we are going to have. This can be written as Bn is same thing as 1 over pi, the integral from 0 to pi. I'm trying to split this bracket and I'm trying to split it into, I'm going to have pi sine nx dx, then minus 1 over pi from 0 to pi, you have what? X sine nx dx. So this is what we are going to have now. If you look at this carefully, from the first part of this pi cancel this pi over here. So we have the integral from 0 to pi sine nx dx for the first part minus 1 over pi integral from 0 to what? Pi x sine nx dx. So if I should integrate the first half of this my integral, I'm going to have this is equal to, if you integrate sine, you are going to have what? Minus cos. So I'm going to have minus cos nx. So you have to divide by what? By n. So all over what? N. Then let me put my limit from what? Is 0 to what? Pi. Then minus 1 over pi. The integral from what? Is 0 to pi x sine nx dx. So now this is going to call for what? For the use of our integration by parts. You should recall that from integration by part, if you should have the integral of u dv, this is same thing as you integrate your dv minus u prime, you integrate your what? You're going to integrate your v again to have your v2. And if you look at this place, this serve as our u, and this one serve as what? As our v, as our what? Dv. This is our u. So now let me substitute what's called the limit of this one. We should still keep this one aside and try to solve for this part. So let's move, guys. So this is equal to minus cos nx over n from 0 to pi minus, if I solve for this one over here, if I solve for this one, this is what I'm going to have directly. So after integrating by part, this is what we're going to have. This is what we're going to have now. So you should also recall that we have to put our upper limit and our lower limit in each component now. So by putting my upper limit in the first half of this guy, I'm going to have I'm going to have now, if I should put my upper limit and my lower limit in this part, I'm going to have this. So the next part that we have to discuss about is this part actually now. So if I should put my upper limit over here, I'm going to have minus pi cos n pi. And again, if I put my lower limit in this place, if I put my lower limit now, which is 0 on this place now, is 0. This one is what my x will turn is 0. 0 times cos will be 0. 0 over n is what is 0. So putting your lower limit here will turn to what will turn to 0. And this particular part now, putting pi and 0, putting your upper limit and lower limit in front of sign will make it what is 0, because we should recall that, let me draw a small box over here, that sine is 0 is always what is 0, which same thing as what sine pi, which same thing as what sine pi of maybe 2 or n pi. Let me put that what n pi, we same that what is 0. So whenever we have sine of 0, sine of pi, sine of 2 pi, sine of 3 pi, sine of 4 pi, sine of n pi, we always give what is 0. That's why this particular part now is equivalent to what to 0. So let's move. So over here now, this pi we cancel this pi, and minus times minus will give us what plus. And you know that cos of is 0 is what is 1. So I can write everything as minus cos n pi minus 1 over what over n. This is same thing as plus. I'm going to have what cos n pi over what over n over n. So this is what we are going to have. If I should proceed a bit also, this is same thing as, I will use this minus to multiply what I have here. So I'm going to have 1 minus cos n pi over n, then plus cos n pi over n. If you go back to our basic mathematics, you can see that this fraction are what? These two fractions, they are like fraction. So therefore, this cancel this. So what do you have left? We are left with 1 over what? 1 minus cos n pi plus cos n pi all over what? N, which is same thing as 1 over n. So therefore, the value of our bn is now equal to what? 1 over n. This is the value of what? This is the value of our b. Now, if you now go back to what? To our Fourier series, and before you go back to our Fourier series, you should recall that your a naught for this given function is 0, and your an is also what? Is 0. Now let me write out my Fourier series formula series that we have now. And you should recall that the value of an, our an has turned to what? The value of our an is 0, and the value of what? Of our a naught is 0, and our an is what? Is 0. If I put 0 here, it will turn everything here to what? Is 0. This one also turn to what? Is 0. So what are you left with? Only left with this guy. So therefore, the given Fourier series part that we'll be using, which is for odd function, is what? Is the summation as n stands for 1 to infinity of bn sine nx. So what is the value of our bn? The value of our bn is 1 over 2. This is the value of our bn. This is the value of our bn. So let me substitute the value of our bn in this last part of the Fourier series. So our f of x now is equal to what? The summation as n starts from 1 to infinity, 1 over n sine nx. So the next thing that we are going to do is what? Is to write out the breakdown of this summation, which is same thing as the given Fourier series that we're going to have as our final answer will now be what? My n starts from 1. So I'm going to put n equal to 1. I'll put n equal to 2. I'm going to put n equal to 3, n equal to 4 like that. So for the first, I'm going to have sine x. While for the second, I'm going to have what? Sine. Since my n is now 2, I have sine 2x over this my n, which is what? 2, plus sine 3x over 3 plus. So the Fourier series is going to continue, which is what? Which is the required what? Required Fourier series or what? Of the given function. So kindly subscribe to Rock Math Class for more exciting video. And in the next class, we're going to solve another example on what? On even function. Kindly subscribe to Rock Math Class. Kindly subscribe to Rock Math Class. Bye bye.